Well, I mean, like, yeah, my answer's not on that poll, but I wrote about as expected.
So what is your answer?
I mean, it's not as difficult because of how you explain it, but it's more time consuming because of the amount of problems. I mean, just an algebra student, but between the support and algebra, it takes a significant more amount of time. But
Mhm.
at the end of the day, it's understood. It's not just remembering formulas and stuff like that. If that makes any sense.
Let me share the results with you so that you'll know what everyone did. Easier than expected was 29%, about the same is 50%, and harder than I expected is 21%. So that's kind of the way it's falling. And this group right here that's in the harder than I expected, then my goal is to try to help you get through here so that it's not quite as hard as it is for you right now. Maybe we can get to the point where it's not quite as hard. I will say that some of the concepts will start repeating themselves. And I've already added some things at the end that I know you're going to have. And so those will repeat. So some of the concepts will get a little easier because we've already talked about them. I knew they were coming and we just talked about them early. So hopefully those people that say it's harder than I expected, maybe before the end of the course, some of the concepts will seem a little easier to you. Okay? Any questions about that? All right, let's talk about tonight's review. Tonight I'm planning on going from 25 back down to 1 because the harder ones seem to be at the end. And I want to make sure I cover that for those college algebra students that drop off at 7:15 if they want to. And so I'm going to start with the last one and go toward the front. Front ones are easier. But as I'm doing this, when you get stuck or if you get stuck, then let me know. If I go too fast on it, then let me know and I'll slow down. Number 25 says find and simplify the difference quotient. All right, they give you an f of x to start with. It's negative 4x squared plus 7x plus 7. Now, for the difference quotient, I'm going to write it over here and then I'll rewrite it again in a minute. This is what it is. It's kind of like Brooke was talking about. It's one of those little formula things. It's what you're going to use it again if you're going into business. You'll see it a lot. F of x plus h minus f of x over h is called the difference quotient. It's actually the first derivative of curve. This curve happens to be a quadratic. And so it's used for lots of things in engineering and in business and lots of places. But let's talk about how to do it. We have the f of x, which is this little portion that I'm going to need right here. We need this one. So what we're going to do is find that one. We're going to put x plus h in the place of x in every one of these spots. So if it says x in it, I'm going to take that x out and put in x plus h. So it looks like x plus h quantity squared plus 7 times x plus h plus 7. It looks like one of those I did at the beginning, kind of. Right, just like we did before, I'm going to put down the negative 4 and I'm going to write down this x plus h twice and multiply it out. And I'm going to distribute my 7x while I'm there, my 7 while I'm there over the x plus h. And then so far, that's what I have. Now, the next thing I'm going to do is multiply this binomial out. I'm going to leave this 4 here and put a parentheses. And I have x squared plus xh plus xh plus h squared. plus 7x plus 7h plus 7. Now I'm going to distribute my 4, my negative 4. Negative 4x squared minus 4xh minus 4xh minus 4h squared plus 7x plus 7h plus 7. It's a long string of terms. Okay, now I'm going to simplify it a little bit because I'm going to have to substitute it in that spot up there that says f of x plus h. So I'm going to try to get rid of some of these terms. 4x squared goes there. These two things right here are xh's. I don't have any other xh's, but I can combine those two and it will make it a little bit smaller. One character smaller, one term smaller. And then I've got the minus 4h squared plus 7x plus 7h plus 7. Okay, now that is my f of x plus h. Any questions on what I've done so far? Okay, now I'm going to rewrite my f of x plus h minus f of x over h. I'm going to rewrite that because I'm going to show you what I'm going to do. F of x plus h. This says f of x plus h, and this is the answer for it. So I'm going to take this f of x plus h out, and in that spot, I'm going to put negative 4x squared minus 8xh minus 4h squared plus 7x plus 7h plus 7. That's where I'm going to put it. So I'm going to scoot it over a little bit. Okay? See that I just substituted that in. Okay, now this part says f of x. So I come up here and I see that I have a f of x right here. And that's equal to this one right here. So I'm going to take this f of x out, and in its spot, I'm going to bring that f of x information down. And notice there's a minus. That's what's called a difference quotient, minus negative 4x squared plus 7x plus 7. Notice I put it in a parentheses because that minus is going to change the signs on it. Okay, so far all I've done is I have f of x plus h was this long thing I got, and I put it in that spot in the difference quotient. And f of x is this, so I bring it down and I put it right there where the f of x used to be. And now this is what I've got. So I'm going to write it all down, and hopefully I won't make a mistake writing it down. And I'm going to change the signs on those last ones because there's a minus in front of it. The first one, there are not any sign changes. But once I get over here, because of that minus that's in that difference quotient, it's going to change every one of those signs. So I'm going to have a positive 4x squared, a negative 7x, and a negative 7. And I'm hoping that those sign changes is going to allow some things to cancel. Sure enough, it does. The 4x's go away, 4x squares. The 7x goes away, and the 7 goes away. So those cancel out. So then you have a negative 8xh minus 4h squared plus 7h, all divided by h. And do you see there's an h in each one of those? So you can take out an h, and you'll have a negative 8x minus 4h plus 7 divided by h. The h's will cancel. The answer I put in the box is negative 8x minus 4h plus 7. Okay, are you still with me? Did I scare you off, or you okay?
We're good. At least I'm good.
Okay. I don't know why this problem is so hard for some people, except that it's long. I don't know why it seems to be so hard, but I know some people have trouble with it.
It took me a whole sheet of paper like that to do the one on the quiz.
And it will take you a whole sheet of paper to do it. If you're just real careful, if you're real careful and will follow the steps, though, you should get the right answer. And I will go in and check these 3 terms to see how close your answer is if they count it wrong. And let's say you had 2 out of 3 of them, then I'll give you the 2/3 point on it. So you'll get.
So if like we don't fully simplify, but you saw that we're close, we'll still get partial credit when you go through.
Like if you give this answer instead.
Yeah, or forget. If you.
I'll give you some credit on it.
Okay. The reason why I missed this one is because there's just too many elements. I think I put 4x squared like positive instead of negative 4x squared.
Do you know why it's negative?
Ruined the whole. It's just attention to detail.
Yeah. If you forget this negative right here, when you distribute it, all those signs are going to be wrong.
Yep. Just, be super careful when it comes to these long problems.
I think if you kind of just take your time, because you're on unlimited time, and I almost think that you could skip to 25 and do it first when you're fresh. And it might help you, because if you do all those other 24 before this, by the time you get to this one, you're tired. So you might want to do this one first and then work backwards. You can do that. Just go to 25 and work it first. That's what I would do. I like to do the hard ones first. That way my brain's not so cluttered when I do the easy ones, and I have a better chance of scoring well. Any other questions on this before I move the sheet? Now, that's definitely the hardest one on the test, is number 25. Okay. All right, let's go to 24. 24 says, this is another one of those, for the function, construct and simplify the difference quotient. Okay. This time they give us f of x, and this one's not as bad as that other one. It doesn't have the squared term in it, so it's not so bad. So remember, what I really need for my difference quotient is the f of x plus h. That's the part that seems to be hard to remember to do. But I'm going to put the x plus h in the place of x. So I have 4 times x plus h plus 9, which gives me 4x plus 4h plus 9. So I have my 2 values I need, f of x plus h minus f of x over h, and they will give you that. They'll give you the difference quotient in the problem. You don't have to memorize it or anything. So for this part right here, I'm looking for f of x plus h. So that's that. I've got it. It's right there. And all I do is take this out and put that in its spot. So I have 4x plus 4h plus 9. We'll put it in a parentheses. I'm going to bring my minus that's in between there down. And now I'm looking for f of x. Well, f of x is up here. So I pick this 4x plus 9 up, and I bring it down here, and I put it in the place of f of x. So I'm going to take that out, and in its place, I'm going to put in a parentheses 4x plus 9. Don't forget that it has an h in the bottom. Now let's take away those parentheses and see what we have. We have minus 4x minus 9. And so your 4x's will cancel and your 9's will cancel. And you have 4h over h. Your h's will cancel and you'll have 4 for your answer. Okay. Any questions on that? Yeah. Did I lose anybody on that one? You good?
It still confuses me when you do the f of x, then f of x plus h, then you take the 4 out of the x plus h. I always want to put 4x plus 9 plus h all in the same parentheses.
Oh, well, what's happening is you're actually using this little x and taking it out to put this value in its spot. That's what you're doing to get that f of x plus h. You're taking that x out, and in its spot, you're putting this.
Okay.
Does that help you?
I feel like it could be expressed in an easier way. All of the, when it's a function in f of x, I just feel like it should just be x. But it's written.
Okay, if it had, let me ask you this. If you had f of a plus b, what would you do?
Well, now doing what you told me, I put a plus b
in the place of
the x in f of x.
That's what you would do.
But yeah.
But see, the only difference is it's repeated this x, and that's what makes it hard, because you got
there. That's exactly what it is. So yeah, I just don't like double variables with the same value, I guess.
Yeah, I understand that. I wish I could fix it and just change it to a different thing. I guess.
Well, because in computer programming, you can't do that.
Yeah. Yeah.
You can't have two values that equal x and have them have the same thing. It just doesn't like that. And I guess I'm short circuiting on that.
Well, this is actually a whole different value. It's got some h added to the x. So this x up here, if it would say was 3 and h was 4, then this value right here would be 7.
Yeah.
So it's actually two different ones. Does that make sense? So this x and this right here is two different things. And I don't know about computer programming. If you can program that with the x, I think you can. I think I think I could do that. I think you can do that. Let's try 23. They're going to get easier maybe. 23, for the piecewise, some of you haven't had a lot of practice yet with piecewise functions, so you might not like this one as much. I did help a couple of students on the phone with these that they were having trouble with. They want you to find h of -7, h of -2, h of 5, and h of 9, those. And they give you a piecewise function with 3 parts, -3x minus 9, if your x's are less than -6. So if this is 0, let's say, and this is -6, then I'm talking about numbers that are over here like -7, -8, -9, and so on. That would be the area that I'm talking about. So if my x's that are in these little things fits this area, like this one, -7 is going to be in this area, then I would use this little rule, -3x minus 9 for that one. But see, there's a whole bunch of numbers that's not in that rule. So we have some other rules to use. Let's say 5. This one was a problem because it didn't have an x on it. For -6 is less than or equal to x is less than 5. So this is our area between -6 and +5. And it includes the -6 and does not include the 5. So this is areas like -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, and any of those fractions that are in between there. And notice there's no x for you to substitute the value in. It's a constant. It's just plain old 5. We'll talk about that one in a minute when we find one that fits. And then the third rule is x plus 6. And that's for the x's that are greater than or equal to 5. So over here where 5 is, this would be a bracket. And I'm talking about numbers like 6, 7, 8, 9, 10, and so on. So it might help you to draw the little areas that you're talking about and then find where it fits. So if I'm looking for h of -7, I'm looking for an x value that fits this -7. So it's right there. See that? So that tells me I'm going to use the -3x minus 9. That's what I'm going to use because that's where that x fits. Now, I'm going to put the -7 in the place of x on this one because it does have a place to put in my value. So that gives me positive 21 minus 9, which is 12, I believe. So that's my answer for the h of -7. Now, that takes care of that one. Let's try this one, h of -2. First of all, I got to find out where this x goes. -2. -2 looks like it's right there. So it's going to be in this little middle area, and this is a problem because there's no x's. But it's a constant that one's going to be. So this is just plain old equal to 5. I don't put my 2 in anywhere. No place to put in 2. So your answer is just the 5. That one was a little stinker for some of you. I noticed a lot of people missed that one. In fact, I had one of the students just made up one. They just said 5x and just put an x with it and said that's going to be -10. But there's no x there. So it's just a constant, the number 5. H of 5. Let's try to find that one. H of 5. If my x is 5, do I use this one, the middle rule, or the last rule? Which one do I use?
The bottom, because 5's included.
Because it's got that bracket. See that bracket? So I'm going to use x plus 6. And I'm going to actually, it has an x, so I'm going to put that x in there. 5 plus 6, which is 11. Takes care of that one. And then there's one more, h of 9. And which one is 9 going to be?
The bottom one.
The bottom one. We're going to use x plus 6. We're going to put the 9 in the x spot. That's 9 plus 6, which is 15. Any questions on how to do that? I know that this one is a problem because it didn't have a place for you to substitute your -2 and you don't know what to do with it. But it's okay. Notice that that's going to come up. So if it doesn't have a variable on it, just use the constant as your answer. Later on, we will actually graph these, and you'll see that that part is going to be a part of the graph that goes straight across at the number 5. This one's part is going to go down, and this it's going to look like that on your graph. And this part right here is always going to be 5 at the y = 5 section. So for those values between -6 and 5, you're going to have this constant section. We'll be graphing one of those soon. Okay, let's talk about 22. We want the relative maximum is blank at x equals blank. Relative minimum is blank at x equals blank. Then they want the interval increasing and an interval decreasing. There's no constant on this one. And the graph, kind of draw this over here. Sometimes I don't like to draw the axes in there because I'm just using the points anyway. This point is 2, -1, and that one is given. You don't have to find it. They give it to you. And this one is 10, -33. And again, those are given to you on the picture. You don't have to find them. You have to count over and down and get it. All right, so now you have to fill in the blanks until the area is increasing and decreasing. So let's talk about this point. Is this point at the top or at the bottom?
Top.
Top. So it would be a relative max. Now, notice you have a 2 and a -1. This is the y value. This is the x value. I usually go ahead and put my x in. That way I don't get confused about which one goes where. When it says that x equals, I'm going to go ahead and put my 2 in there. Then that means this other blank is my y value. And my y value is -1. So that means this one is my minimum value. This one's a maximum. This is a minimum, and it's relative. Remember, we talked about there's a little area in here, and it's relative to that little area there. That's what it's relative to. So this is a min, and again, I do the same thing. I put my x in first. And then I say the minimum value is -33. Okay, let's talk about increasing. Remember, this is intervals, so I'm thinking use parentheses, use the x values, and go left to right. Those are the 3 things I always remember when I'm doing intervals. So I'm going to draw my little car on here because it helps me. I don't know if it helps you, but it helps me to do that. That one looks like it's going uphill, left to right. Uphill is increasing. So I'm increasing from, anybody want to tackle it?
-infinity to 2.
-infinity to an x value of 2. Okay. Is there any other place that it increases?
10
to positive infinity.
Yeah.
Y'all are getting better at these for sure. So from 10 to positive infinity, it also increases. So that means in this little spot right in here, this is a decreasing section. It's going downhill. So what would be my interval decreasing?
2 and 10.
2 and 10. Good job. Any questions on that? Okay, that's what you can expect for 22. Let's look at 21. 21, it says determine the relative maximum or minimum and intervals. They're going to insist that you learn this. Increasing and or decreasing. Okay, now it does the same thing. It wants to know if a maximum or minimum, and they give me a picture with the ordered pairs on there. So these ordered pairs are negative 2.5. So you can expect that this one's going to have some decimals on it. And 3.25. Okay, so the first one is that you're going to have relative max or relative min, and you have to decide which one it is. So what would it be?
Max.
It's a max.
Relative max.
And the points are already on there. You don't have to find the points like you do on some of the problems we have. It has x equals blank and has they use the word value of blank. And so I do the same thing. I go for my x first. My x is negative 2.5. That means this has to be the other number, 3.25. That's your y value. The word value is usually associated with the y. Now then, let's talk about interval increasing, interval decreasing. Okay, increasing left to right, going right from here to there, would be negative infinity to negative 2.5. Decreasing is going to be negative 2.5 to positive infinity. Any questions on that? Yes? No? We good?
No, ma'am.
Okay. Everybody okay? Have you found some problems you think you can do? I hope.
Yes, ma'am.
Good. Find intervals increasing, decreasing, constant. This one has a constant section. And that's all it asks for. And it's a picture that looks like that one we had earlier. So you can expect that this is going to be one of your pictures. So what you're going to need to know is those points there. This point is negative 6, 2. And you'll have to put your points in. You need to put in the points on this one. So you'll have to put one there, and you need to put one here. The point here is negative 4, negative 2. The point here is negative 1, negative 2. The point up here is 0, 6. Now, since this problem does not ask for range or domain, just to keep yourself straight, I would go through and mark out these x's, these y values, not the x's, the y values if I were you. Because that will keep you from using those maybe. Okay, we want to go left to right. Remember the rules. Left to right. Use parentheses and use the x values. Okay. Let's pick somebody. Lori, pick one and decide what it is.
I will do increasing.
Okay.
It's increasing at negative infinity to -6,
Mm-hmm.
comma, it's also increasing at -1 to 0.
Good. Okay, Amanda, pick one.
It's decreasing from -6 to -4.
Good job. Constant. Let's see. Astanika, can you do the constant?
Sure. -4 to -1 and 0 to positive infinity.
Good job. Okay. I hope everybody can do that one. You'll have to put in the points. And then if you're having trouble with these, take out those y's and just that'll help you to remember to just use the x's. Okay. We're doing good. We've done the hardest
We're
problem.
gonna have to find those points with our calculator.
I'm sorry, do you have to what?
We have to find those points with our calculator.
No, there's a grid in here. There's a grid that comes down through here.
Okay.
It goes through that point actually.
Okay.
Comes down through here. It's -3. It goes like that. There's a grid on there and you can count them. Count the little squares. Good question though. I don't know that I would draw the grid. I think I would just draw the picture and then use your grid that's there to actually put in the points, because sometimes your grid gets in the way of where your points are. So I'm not sure I would draw the X and Y axis. I'd probably just draw the shape of the figure and then put in the points. Okay, let's look at number 19. Number 19 says f of x equals x squared for x less than -5, 7x for -5 is less than or equal to x is less than 3, and x minus 3 for x is greater than or equal to 3. Notice that this one, like that other one we had a 5 in there, this one's got an x on it. So if we had to do a bunch of them, we would have to substitute in for those x in every case. But this one just says, which rule would you use to find f of 3? It doesn't ask you to find it. It asks you which one of those equations would you use to do it. So be careful. Don't substitute your 3 in and get the answer. It just asks for which one of these things, the x squared, the 7x, or the x minus 3 would you use. And you're looking for an x value of 3. So which one do you think it would be?
The last one.
The last one. So all you have to put in the blank is x minus 3. Don't try to put that 3 in there and find the answer. It's the rule that you want. That's what it asks for. Any questions on that? Number 18, I would grab my calculator and put this on my calculator. That's what I would do. And they're going to have some pictures. They're going to have an A, B, a C, and a D. And One of them looks like this. One of them looks like this. One of them looks like this. And one of them looks like this. So look on your calculator, grab your calculator, and all you're doing is finding the right picture. Do your y. Is it C? Let's see. Second, and the x squared key would be the square root key. Put 6x minus 5. Make sure it's all underneath your radical. And graph it. And which picture is it? Somebody said C already. That's right. And they're very different. So you shouldn't have any problem finding the correct one if you put it in your calculator correctly. Just make sure you've got it in there the right way. Okay. Now 17 is the same way. 17 says graph, and it has f of x equals the square root of x minus 7. And one of them looks like this. That's A, I think. One of them looks like this. And one of them looks like this. And one of them looks like this. So which one is that? Which is the right one?
A.
I think you're right. Second square root x minus 7. Okay, it looks like it's this one. Any questions on how to do that? So for sure, you're going to be able to get those three that's on this page, for sure. You can count those right. Okay, let's go to number 16. Number 16 is determine the domain. Now this one might be a little hard for some of you if you can't remember how we did it. It's a square root problem, and you have 5x minus 7. So how do we find the domain on a radical? Does anyone remember? We'll put it on my
Can we
calendar.
graph it and put it in second table, and then I'm trying to make sure, right? Because the domain is all the x's, and then the ranges is all the y's.
So it looks like our x's start from right here, wherever that is, and goes this way, doesn't it? Doesn't it look like that? And if I did the table like you suggested, I can see there's a bunch of errors here because somehow it doesn't count anything until I get to that point where it starts. And where it starts is somewhere between 1 and 2, looks like. Because 2 is 1.7321. So I wonder if I can find out what that exact value is. Does anybody remember how I can find out what it is? Something about that radican.
Set it equal to 0.
Well, if you set it equal to 0, you're certainly going to find that point where it starts. But the way we did it in class was to find the domain, and it will be one of those greater than or equal to things. Greater than or equal to 0. See on my graph? The graph's going to go this way. So it's greater than or equals to some number right here where it's starting. And to do that, you just set it greater than or equal to 0. And you can get 7/5, which is actually 1 2/5. 7/5. Now, the way they're going to have this one is they're going to have x is greater than 7/5, x is less than or equal to 7/5, x is greater than 5/7, x is greater than are equal to 7/5. And you have to find out which one's the right one. Okay? Notice there's two that are pretty close to the same. And you have to decide whether you want the greater than or equal to or just the greater than. So you have to remember that it can be 0 underneath the radicals. So this is the one you want. Now, let's suppose you couldn't do that. You could do that. Somebody suggested you could set it equal to 0. That gives you x is 7/5. That's the starting point. So if you can remember that that's the beginning, that's where it starts, and it does include that point, then you're home free, because then that would tell you want this one right here. If you add the starting point with your picture, you can see that it starts at 7/5 and it's going to go to positive infinity. Any questions on that one? You need to mark number 16 because some of you may have trouble with it. You need to practice it a little bit. Or keep your notes handy so you'll know what to do on it. Okay, number 15 is one of your favorites. It's the toy rocket problem. This is the one where you don't read the stuff. On the toy rocket problem, don't read the words. Just find the equation. The other stuff that's in there is what makes up the equation. So on the toy rocket problem, all you have to do is find the equation. Okay? Now, I'm going to read it for you so you'll know what it says. It's the toy rocket problem. It's a toy rocket is shot vertically into the air. So we got this rocket shot vertically into the air, and it's going to come up and go down from a launching pad. And this launching pad is 6 feet off the ground there with an initial velocity of 168 feet per second. The height in feet of the rocket above the ground at t seconds after launch is given by the function this. And what this is right here, the highest height. So this is some x and y that is going to be a maximum that you're trying to find. You want to know how many seconds. This is the t, the seconds across here. And the y value is going to be the height. That's what it looks like. Now, you don't need to know all that. All you need to know is that you need the vertex of this. So remember, there are two ways to find the vertex. That's what you want to do, is find the vertex. And I'm going to do the x equals negative b over 2a. That's that first part of the quadratic formula. And in my problem, a is negative 16, b is 168, and c is 6. So I'm going to do negative 168 over 2 times negative 16. And I'm going to see what that is. Grab my calculator and see what that is. I got 5.25. Did anybody else get that? So this value from here to here is 5.25. So that's the answer to my time already. That's my seconds. Now, if I want to get my other value, my height, I stick this 5.25 in my formula. Negative 16 times 5.25, quantity squared, plus 168 times 5.25, plus 6. And I'm going to do that on my calculator on a blank screen here. Negative 16, and use the negative down at the bottom when you start when you start a negative at the beginning. Parentheses 5.25 squared plus 168 parentheses 5.25 plus 6. You can just put it all in your calculator and hit enter, and it'll give you your answer of 447. So you can fill in your blanks then. The rocket reaches its maximum height at blank seconds. Then it says the maximum height reached by the rocket is blank feet. And you have to decide what you want to put. You've got two answers. You've got 5.25 and 447. So where would be the 5.25? Where would it go?
Second.
The seconds. And the 447, where would it go?
The height.
Okay, now let's do it on the calculator. And I've already done this, so I can see that I'm going to have a really large number for my y. But I'm going to show you what it looks like when I just graph it just like I've got it. Negative 16, and you'll have to use x, of course, x squared plus 168x plus 6. And when I graph that on a 10 by 10, I don't get to see much. And it's because it's out of my range of 10 by 10. So if I fix my window that will fit, then I think I can probably get it in there. So the seconds are going to be 5.25. So if I go to window, remember windows where you do this. And if you put, say, -5 and then 5.25, let's put 7. That would cover it. And count by ones. My y min, I'm going to put like -50. And I've got to go to 447, so I'm going to put 500. And I'm going to count by something big, like 50s. And leave your resolution alone, that's fine. Now then, when you graph it, you should be able to see that thing. There it is right there. You can see the top of it. Now let's remember how we find the vertex on our calculator. It's second and calculate, which is the trace key. And this is a maximum, so I'm going down to number 4, or I'm going to hit the number 4. And remember, my little cursor's going there. I'm going to move it up a little closer to my maximum. I don't have to, but I'm going to. And I'm going to hit enter. And when I do, it puts that little triangle there. And then I'm going to go on the other side of it. And I'm going to enter again. Remember, you want to do the left side first, and then you enter again. And it will tell you down here at the bottom that that's a maximum value of 5.25 and 447 for the y. It tells you what it is. So it double checks my answer in case I've made a mistake somewhere, have a sign mistake, or I forgot the formula, or something's wrong. Then it'll help me remember that I have a mistake somewhere. That if this doesn't agree to this, then something's wrong. Okay, do we have any questions about that rocket problem? Remember the toy rocket. You don't have to read all the words. You just use the formula. The little quadratic equation that's there. Any questions? Okay, now how do I get out of this long picture here? Does anybody remember if I want to graph another one, I've got to figure out how to get my graph to not be on this long scale. How do you do that?
Second quit.
Now, second and quit will make it go away, but it won't. If I graph another one, I'll still have those dimensions. How do I get back to a 10 by 10?
Zoom and standard.
Mm-hmm. To get back to the 10 by 10 screen, do the word zoom and number 6, which is standard. So if you go to the zoom button, which is in the middle, and number 6 is standard, then it'll take your screen back to that 10 by 10. So I'm ready to graph other graphs. Okay, are we good on this problem? Okay, let's do number 14. Number 14. Let's see. Somebody told me at the beginning of the class that 11 through 16 were problems, so hopefully this is helping. Negative 4x squared minus 4x plus 1. And we have to have A, what is the vertex? B, what is the maximum value? And does it open upward or downward? C, what is the range? D, where is it increasing? And E, where is it decreasing? So if I were you, I would do this one on the calculator. You can do negative B over 2A, but these are probably easier to do on the calculator since they're not great big numbers and you can see it on the screen. So I do y equals negative 4x squared minus 4x plus 1. Okay, graph it. Looks like it is a maximum. It's going to open downward or upward. What do I put?
Downward.
Mm-hmm. And I think there's a little thing for you to indicate. I need to know the vertex. So if I know the vertex, that will help me with this one, and this one. So what I'm looking for is the vertex on this. Maximum. So I do second and calculate, go down to 4, and my cursor's over here on the wrong side. I'm going to move it over to the left side of the vertex, put enter, makes a little triangle up there. Move it to the other side, the right side, and hit enter, puts the other little triangle up there. And then I hit one more time and it will give me my maximum value. It says negative 0.444499999. So somebody tell me, what is that value?
What buttons did you press on your calculator?
Well, let's do it again. We go to the y equals, graph it. Now I want to know the vertex. So I do second and the one that says calculate. It's the second one over. And see where it says maximum right there? You have to know if it's a minimum or a maximum, but mine's a maximum. So I'm going to hit number 4. See how my cursor's right there? You see it blinking? Can you see it blinking? I need to mark it on the left and on the right. So I'm going to move it over a little bit because I can't exactly tell where it is. And see how it's now on the left side of the vertex?
Yeah.
I'm going to hit enter, and when I do, it puts that little triangle up there to tell me I've marked the left. I have marked the left side.
So are you marking the left side on like a whole value or just anywhere?
It doesn't matter. It can be anywhere.
Okay.
I don't care where it is. It's just got to be on the left side.
Uh-huh.
Then you move it over here to the other side, make sure it's on the right side somewhere of the vertex, and hit enter again. And see how it put that little triangle up there? That tells me it marked that side. Now hit it one more time. You have to hit it that third time, and it will tell you it's a maximum, and that's the maximum X and Y. Now this is what my calculator has. X equals negative 0.499999989, and Y equals 2. So I need to know what this is. What is that number?
-1/2.
It is. It's negative 0.5 if I rounded it. And negative 0.5 is -1/2. And it does ask for fractions on this. It says down at the bottom, use fractions in your answer. This one does say that. So instead of 0.5, I'm going to put -1/2. Now, if you put -0.5 and it counts it wrong, I will go in there and correct it for you and count it for you. But it does ask for you to put it in fraction form. So the X value of the vertex is -1/2 and the Y value is 2. And that answers this problem up here, -1/2, 2. Okay. So what is the range on this problem? Remember, the range is the Y values. And we want to go bottom to top on range. So if I start down here at the bottom and I go as far as I can go, where will I go?
-∞ to 2.
Negative infinity. And why did you use 2 instead of 1/2?
Y value for the range.
It's a Y value. Very good. Does it include the 2?
Yes.
Yes, so I'm going to use a bracket on that one. Now we go to our famous increasing and decreasing intervals. These are the ones where you use parentheses, you use the X values, and you go left to right. So increasing, anyone want to make a gamble on the increasing one?
-∞ and -1/2.
And how about decreasing?
2 and infinity.
Did you say 2?
-1/2.
Or -1/2 and infinity.
Remember, when you're doing intervals, mark out the Y's. -1/2 and positive infinity. Yes. Now, could you have used the -b/2a on this problem for X and then put it back in to find Y? Could you have done that? Maybe. You know, before we did, on that big one, we did X equals -b/2a because the numbers were big. Could we do that on this one? Maybe? Yes. You could do that on this one and you would get the -1/2. Then you'd have to put the -1/2 in for X and find Y, and that would give you the 1/2. And your calculator will do it for you. You just have to put it in correctly.
So for when we're doing range and domain, do we use like brackets?
Yes. Range and
Use
domain,
brackets?
you use brackets if it includes the point.
And you don't know why Blackboard or My Math doesn't use those signs? Like,
What signs?
it'll give us a list of signs like the up and down. I don't know. Does anybody else know what I'm talking about?
Because
When you're
you don't have the
interval
bracket
notation?
sign down there.
You have to use your keyboard.
You have to
Yeah,
use your
okay.
keyboard to
Alright.
get that one. And To use the bracket and the parentheses is on your
Yeah.
keyboard. That's a
Okay.
good question, actually, because most of the time they have all the symbols down here at the bottom, but they
Yeah.
don't have that one. And that's
Yeah.
on your keyboard. It's next to the P
Well,
on your keyboard.
yeah, and it can be well, it's multiple because you can also use the curly mustache, and we've used that before, but it only takes brackets.
It only takes brackets and parentheses. The curly
Okay.
mustache one is something else. It's gone out of my mind. And that one is set notation, and they usually give you options for set notations.
Oh, okay.
They don't make you write that in. That's a great question. Yeah, it's hard to find that little, you're looking for it down here on your list of tools, and it's not down there. It's next to the P.
Yeah, I'm pretty sure I lost some points on that.
Yep. All right, I'm glad you brought that up because I had forgotten that. There were several students that had trouble with that. Let's do the next one. What was that, 14? So we're on 13. 13 is find the vertex. Same thing. You're doing the vertex. You're doing in this one, it goes ahead and tells you it's the minimum value, and it has a blank. And C is the range, and D is increasing, just like that last one, and E is decreasing. Why do you think they're not asking for the domain on these problems?
Because they're never ending?
That's right. They are always going to be on a parabola. Negative infinity to positive infinity. That's a great answer there. Okay, let's try this one. This is x squared plus 8x plus 15. And I can see it. It's right there. Don't have to move anything. I can see that parabola. Looks like this. So is this number going to be a maximum or a minimum?
Minimum.
Well, I already told you in the problem. It really, So this minimum value we got to find. So let's use our calculator. Can we do it? How do we do it? Somebody remind me.
Second, calculate.
Second, calculate. And this time I want a minimum, so I'm using number 3 instead of number 4. And I want my cursor to be on the left side, and I can't see my cursor. It's not there. I don't see it blinking anywhere. But if I look down here, I can see that it is x is equal to 0 and y equals 15. It tells me my blinker is up here somewhere. So if I want it to come down, I'll have to use this left arrow. And in a minute, you'll see it. See it? It's starting to come down there. But I've got to move it to where it's over the left side of where the vertex is. Okay? We'll move it like to right in there. I don't really care where it is as long as it's on the left side. And then I hit enter. Puts that little triangle up there. Watch for that. Then you use your arrow key and put it over on the other side, the right side, and hit enter. Watch to make sure it's there. And then hit enter again. And it will tell you the minimum value. It says my minimum value is -4, -1. I don't even have to worry about any fractions. So that answers A. And the minimum value is the y value. The y value is -1. Range. Anyone want to make a guess of what the range is? It's going to
Bracket,
bottom
-1,
bracket, -1
infinity, parentheses.
to positive infinity in parentheses. Okay, intervals increasing and decreasing. Anybody want to try that one?
It's increasing at -4 to negative infinity.
Well, increasing is this way. Is that
Oh, positive.
positive infinity? Okay, how about decreasing?
Negative infinity to -4.
Okay, good job, guys. Now, some of you are very quiet during this section. Is there something that you didn't understand about one of the sections of A through E on this answers?
The domain and range has always been like an issue for me. So
Remember, range is bottom. You have to do the very bottom of it. So start down here and keep going till you get to the very bottom point. And wherever that is your bottom number for your range. And then just keep going up and see where it's going to go. And these arrows means it's going to keep going up forever. So, and remember, range is always the Y values. And it's bottom to top. The domain is left to right, and it's the X values. But it's not going to ask you for the domain because those are just two easy points. They're in negative infinity to positive infinity. So it's only going to ask you for the range because that one changes from problem to problem on these parabolas. Okay? Take your pencil or something and make it go up. Draw a picture of it. And when you hit the bottom one, that's your Y value there. Remember, you use Y values on range. And then when you get down here to increasing and decreasing, then take that Y value out because you're using X values on increasing and decreasing. Okay, let's try 12. Number 12. Determine whether the statement is true or false. The graph of h of x equals x minus 3 quantity squared can be obtained by using h of x equals x squared and going right 3 units. True or false? So you start with a parent graph. In this case, it's x squared. What does this do if it's inside the parentheses? Is it left or right or up or down?
Left or right?
And if it's minus 3, you think opposite. So it's really what?
Right.
Right. Now, if you want to, you can actually graph this and see where it's moved from that basic graph. Put the x minus 3 squared in there, and you can see it's shifted over to the right 3 units. You can see it doing that if you just graph it. Okay, let's do number 11. For the function below, find the vertex. This is another one of those problems. They like these. This time they've added the axis of symmetry. And determine if it's max or min. And graph. Okay, so we've got the function is 2x squared plus 10x plus 8. And we want to graph it. 2x squared plus 10x plus 8. And we're going to graph it. There's my vertex. it looks like that one is a, what do you think, max or min?
Min.
It's a minimum. And we want to know the vertex. If we get the vertex, the axis of symmetry is kin to that vertex. It's just the x value of the vertex. So let's do our calculator to graph it. It will be faster to do that. Looking for a minimum this time. My cursor's right up there. I'm going to move it over to the left side of the bottom there and enter. And go to the right side and enter. And then enter one more time and it will give you the minimum. And they have x equals negative 2.499999 and y equals negative 4.5. So what would I say my x value is?
Negative 2.5.
Mm-hmm. Now, this is another one that asks for fractions. So do you know how to change it? Do you remember how we talked about changing this on your calculator? 2.5, there's several ways. I think Luke had another way, and maybe somebody else had another way too. You can go to math and hit fraction there at the first, and it will change it to a fraction for you if you don't know that negative 2/5 is really negative 5/2. You can do it again on your other one, the 4.5, and I didn't put the negative on it. Go to math, and that first one is fraction. Just hit it. It says it's going to change 4.5 to a fraction, and that one is 9/2. And again, if you forget to change it, I'll go ahead and count it for you. Negative 5/2, negative 9/2 is your vertex. What is your axis of symmetry? Does anybody remember that?
X equals negative 5.
X equals negative 5/2. It's whatever the x value is of the vertex. But remember, you have to put that x equals. If you don't put the x equals, they will count it wrong, because the axis of symmetry is an equation. Now, this graphing part, I would graph my vertex first. I would grab my tool. You'll have to use the little parabola tool. And I would graph my negative 2.5, negative 4.5, 1, 2, 3, 4.5. I would graph that one first. Now, if it's not going to show you up here that you're wanting negative 2.5, negative 4.5, if that's hard for it to do that up there in that yellow area, then you don't have to graph that point. You can graph some other points. I would go to my table and pick some points off. Looks like negative 1 zeros on there. That's a great point. Let's go up some. Negative 2 is negative 4. Negative 3 is negative 4. So you've got plenty of points that you can use to graph that thing. So then you graph it, and you're home free. You're done with that one. Okay, any questions on that? What are you thinking about so far? Anybody have an opinion of this test?
I actually think it's a little easier than the last one.
You think it's easier than the last one? I think some of the material is repeating. Okay, this one has this information at the top. Use the graph of the quadratic function f of x equals a times x minus h quantity squared plus k to find the vertex. The axis of symmetry and the minimum or max. Now, it gives you a picture. And in the picture, you'll have to find out what the vertex is, but it's pretty easy to find. You can just count over and find it. This point is -2, 2. This part up here about using the graph of the quadratic function and this part you don't need. Just use the graph. All you're wanting is the vertex and the axis of symmetry and if it's max or min. So don't even pay attention to that up there. This is that standard form. I'm sorry, that's the vertex form. And just don't worry about using that. You don't need it. -2, 2 is your vertex. The axis of symmetry is x equals -2, and you can see that it's a minimum. So don't let all those extra words confuse you. Any questions? Okay, let's do this ladder problem. The ladder problem is going to be on here, guys. And it's a ladder problem from the wall. Here's the ladder that goes up. And you just have to remember that this is a Pythagorean theorem problem. So draw your little picture so that it's a triangle. This is the ladder problem. And it's going to be number 9 on your test. The foot of the extension ladder is 5 feet from the wall. Here's the foot, and it's 5 feet from this wall right here. This is the wall. So this is your 5 foot right there. Then it says the height that the ladder reaches on the wall, this height, and the length of the ladder are consecutive integers. And you just need to know that the rule is x is the first one and x plus 1 is the second one. And x plus 1 is going to be bigger than x because it's one longer. So this side's going to be x and this side is going to be x plus 1 in this problem. When you see number 9, that's what it's going to say. The foot of the extension ladder is 5 feet from the wall. Now that 5 feet might change to 6 feet or 7 feet or 12 feet. But the other two parts of it where it says the height that the ladder reaches on the wall and the length of the ladder are consecutive integers. That's going to remain the same for this problem. So this one's going to be x and this is going to be x plus 1. This number down here might change to a different number. So you're using the Pythagorean theorem that a squared plus b squared equals c squared. That's called the Pythagorean theorem. And so this one down here is your a part that goes with that 5. This one going up will be the b, and c is always the hypotenuse. That's the side opposite this right angle. It points right to it. That's your c. So now we put in 5 squared plus x squared equals x plus 1, and don't forget to put it in a parentheses, squared. So now you have 25 plus x squared equals, and I'm going to write it down even though I could do it in my head at this point. We've done enough of them. I'm going to go ahead and multiply this one out using FOIL. First, outer, inner, last. X times x is x squared. X times 1 is 1x. 1 times x is 1x. 1 times 1 is 1. Now then, normally I would set this equal to 0 because it's quadratic, but I can see ahead that these x squares are going to cancel each other out. So I'm not going to have to worry about those. So now let's see what we have. We have 25 equals 1x plus 1x is 2x plus 1. Now subtract off your 1, and you get 24 equals 2x. Divide by 2, and you get 12 equals x. X is going to be the wall, and it will have No, on this one it says how long is the ladder? It doesn't ask how long or tall the wall is. So I don't need X. That's what my 12 is. I need the X plus 1. So what would that be?
13.
It's 12 plus 1, which would be 13. So don't forget that it's asking for the ladder length, not the height of the wall. Any questions on that?
And that's why I said consecutive integers, because one's 13 and then the X is 12.
That's right. That's a good point to remember. See how this is 12 and the next consecutive integer would be 13? That's the integer that comes after 12. That's a good point. Thank you for bringing that up. Any other questions or comments? Great comments. I believe y'all are getting it. I appreciate that. Okay, then you know that we have this wire problem. This is the wire problem. Okay, let's look at it. I'm going to move it over here so you can see the words. A wire is stretched from the ground. So there's my ground, and it's going to be stretched up here to the top of the antenna tower. They're always going to give you the length of the wire. The wire is, in our case, 40 feet long. The height of the tower is 8 feet greater than the distance D from the tower's base to the end of the wire. So the D is from the tower's base to the end of the wire. So this D is always going to be on the bottom in this problem. And this one, it may say 5 feet greater, it may say 4 feet greater, it may say 8 feet greater, it may say 10 feet greater. But whatever it says here is the D plus that number. In my case, it's D plus 8. Any questions on how I figured out where to put the D and the D plus 8 and the 40? All right, again, this is a Pythagorean theorem problem. So what we've got here is this wire length is 40. This on the bottom is going to be D, and this is going to be D plus whatever number it is they give you there. In my case, it's 8. So we're going to say D squared plus D plus 8 squared equals 40 squared. It's a lovely number. So now we have D squared plus D plus 8 times D plus 8. That's what it means when you square it. And 40 squared is 1600. If you didn't know that, you could do it on your calculator. Now you have D squared plus, and again I'm using full, D squared plus 8D plus 8D plus 64. 8 times 8 is 64 equals 1600. Now, it doesn't look like my D squares are going to cancel in this number 8. It will on 9, but not on number 8. So 1D squared plus 1D squared is 2D squared. And 8 and 8 is going to give me 16D. And I have that 64, and I have 1600 over here. I need to set it equal to 0. So I need to subtract the 1600. And now I have 2D squared plus 16D minus 1536 equals 0. Now you can factor that as an AC trinomial, but it's going to be really long. So what I would do is take out the 2. I can see that there's a 2 in common here, and that will reduce my problem considerably and make it cut in half, and my numbers won't be so big. Now this is a little trick. You can divide out that 2. And now I just have d squared plus 8d minus 768 equals 0. Well, that's great to work with. Now, this is the hardest part of this problem, is trying to figure out how I can subtract factors of 768 to get 8. That minus means I subtract factors of 768. And so if I were you, I would just find any 2 numbers that make up 768. Like, I can see it ends in an 8. So I know that thing will divide by 2. And let's see if you can just break it down further. 768 divided by 2 is 384. And 384 divided by 2 is 192. And 192 divided by 2 is 96. And 96, let's just keep going, divided by 2 is 48. And I could keep going down, but it looks like I might be getting close to, I've got to have 2 numbers that are pretty close to each other. So keep going down and you'll get 2 and 24. So let's try 48 or 24 divided into 768 and see what we get. 768 divided by 48 gives me 16. So 48 times 16. When I subtract those, that's going to give me 32. I need to get an 8. So let's try the next one down. If I do 768 divided by 24, I get 32. And what do I see about 24 and 32?
32 minus 32 minus 24 is 8.
Right. So there's my answer right there. And I did that by trying to break this down into 2s until I got some number that was pretty far down so that when I had 2 things multiplied, they would be close together. So I tried the 48 and that was too far apart. So I tried the 24 and that was just right. But that's just a method for trying to figure out what to use for your 2 numbers when they're big like this. So now I know that d and d will be your d squared there. And I want to use 24 and 32 because when I subtract those, I get 8. And I want my 8 to be positive. So my 32 is positive and my 24 is negative. Okay? So now then, set each one of those equals to 0. And then this one, you get 24. And d plus 32 equals to 0. And you get d equals negative 32. Okay? Now, this one you have to throw away in this problem. This is the only one that you throw something away. This is an extraneous root because you can't have a negative distance. But it is kin because my distance d is 24. And when I add 24 plus 8, I get 32. So I'm going to get that number there. It's just going to be the positive side of it when I put the 8 in. Okay. Any questions on that one? Okay, it is 8 o'clock, isn't it? Yes. So those of you that can't stay one more minute longer, you may leave if you want because the class is technically over. I'm going to continue to work down and then I'll stay as long as anybody needs a question answered afterwards. So do you have any last words of wisdom that you want to say if you're going to intend to leave us at this time?
I don't really have any last words, but I hope everyone has a good break.
Yeah, this is spring break. I hope everyone gets a chance to breathe a little bit.
I think a lot of people are gonna like do something or like go outside or whatever that we couldn't do a year ago. I just can't believe how crazy things have been.
I know. We're going to go see some friends that live in Fayetteville that we haven't seen in such a long time because it's been hectic and hard to travel. And so we're going to go do that. I think.
And more people are getting vaccinated, so it's like finally like things are turning around.
Right. Yeah, I feel a lot better now that I have my vaccine because I feel like I don't have to be quite so cautious about catching everything, at least the coronavirus I'm not going to get maybe. And I got the stomach virus, but I'm hopefully not going to get the coronavirus. So
I just hope that in the future that they can build vaccines faster than they did, because that's really what the problem was, is it took almost a year to create this vaccine. And
yeah. Well, I hope everybody gets a chance to get this test done and behind you and then get a chance to relax. I really think the second half of our course is going to be easier than the first half because, like I said, things are going to start repeating. And so you'll go, oh, yeah, I remember doing that before. And
so when you say repeating, it's like something we learned about, but like adding on to it. Is that what you mean?
Yeah, instead of doing just parabolas, we'll go to some more cubics and then we'll start doing this kind of thing. And so there's relative max and mins all over the place there, but you've already been taught how to do that. And these are called turning points, and we'll talk about that. And, the number of humps that it has, and you could draw your x-axis across there and look, it's going to have a bunch of x-intercepts. So that thing could be a really cool little thing to find all those x-intercepts, but we'll use our calculator and find them. And they're going to be things like you've done before. It's just more little curves that we're going to be doing. So I think that it will be easier for you.
Okay.
Hoping that will anyway. All right, let's continue for everyone that wants to stay. I'm going to go to number 7. This says use the graph to find x-intercepts and solutions. And they give you the picture. There's one at -2, 0 and one at 4, 0. And the graph comes down like this. It's a little parabola. And on this one, notice we're not finding the vertex at all. This is before the vertex came into play. This is the x-intercepts. And for x-intercepts, you need ordered pairs. So you write 1, 2, you'll have to find them, -2, 0, and 4, 0. So you're going to write those two down. And those are your x-intercepts. Then it's going to say, what are the solutions? Well, the solutions are the x values of those solutions where it's crossing the x-axis. So it's -2, 4. So hopefully that will be an easy problem for you to do. It's the same thing. They're just asking you to do them in a different form, either in the x-intercept, which is ordered pair form, or solutions, which is just the x answers. Any questions on that one? Okay, let's do number 6. That one you could go to first and do if you wanted to, because it's really easy. Number 6 is find the zeros. Zeros are solutions, and they give us f of x equals 2x squared minus x plus 10. Now, this is an AC trinomial because there is a 2 in the front. AC is going to be 2 times 10, which is 20. So just take a minute and see if it can factor, because if it can factor, that's fastest. If it can't factor, then you're going to have to use the quadratic formula. Now, the quadratic formula is not going to be listed there for you to use. So you need to have the quadratic formula listed somewhere in your notes. Okay? You're going to need it. I'm going to go ahead and put it because I know this is one that's going to need it, but I'll show you why in just a minute. So write this down somewhere so you'll have it. It's not listed on every problem. I think it might be listed on one of them, but not on every problem. Okay, this is a 20. I must add to get 1. I can't. 20 and 1 is 21. 4 and 5 is 9. 10 and 2 are 12. So none of those work. So I have to use the quadratic formula to get it to work. So my A is 2. My B is -1. Remember, there's a 1 in front of that X there. And my C is 10. And I'll need to use all 3 of those in my quadratic formula. So now I have the negatives in my formula. B is -1 plus or minus -1 squared minus 4 times A, which is 2, times C, which is 10. All over 2 times A, which is 2. So I have 1 plus or minus the square root of 1 minus 8 times 10 is 80 over 4. And that's 1 plus or minus 1 minus 80 is -79. See, anyone remember what I do if I have a negative underneath the radical?
Use the I.
I is equal to the square root of -1. So I can say this is 1 plus or minus -1 times 79 over 4, which is 1 plus or minus the square root of -1 times the square root of 79 over 4. And that -1 is going to change to I. And the square root of 79 is not a perfect square, so I can't do anything with this. Now they want you to write this in complex form, which is A plus BI, which means I've got to split this into 1/4 plus the square root of 79 over 4I, and 1/4 minus the square root of 79 over 4I. So make sure that you understand there are 2 answers that are distinct, one with a plus and one with a minus, and you split this from the bottom up to go under each fraction. And that's that number 6, and you're going to need to use the quadratic formula on number 6. So if you write yourself a note that number 6, you're going to have to go to that direction. You can save yourself a step by not having to worry about whether it'll factor or not. Okay, let's look at number 5. They're getting easier. Number 5 says find the zeros. And you have f of t equals t squared plus 5t plus 6. So you have to put a 0 in that spot and see if this will factor. This is a simple trinomial. I must add factors of 6.
-1.
Six and one. 6 and 1. If I add those, I must add, I get 7. That's not what I need. I have a 5 in the middle.
3 and 2.
What is it?
3 and 2.
3 and 2. 3 and 2 is 5. That'll work. Plus 3. Whoops, I forgot my t. T plus 3 and t plus 2. You see why 6 and 1 doesn't work? I'd have to subtract those to get 5, but this last sign is a plus. That means I
Oh yeah,
must
I forgot
add.
about that. I forgot about that.
Yeah, there's a tendency to just do whatever makes 5. And but you got to find these rules. This means it must add. And 6 and 1 added would be 7, not 5. But 2 and 3 makes 5. Now you set each one of those equal to 0. And you don't have to worry about any negatives you get. It's okay to get a negative in this because there's no ladder or wall or anything to worry about. So I have 2 answers. I think there is a blank and you have to put -3, comma, -2. And it doesn't matter which order you put it in. Just don't put a parentheses. Then the computer reads it as an ordered pair. So be careful not to put parentheses on that number 5. Okay? All right, let's look at 4. Number 4 says, describe how the graph can be obtained from a basic graph. And then it says start with the graph of h of x equals blank. And this problem is g of x equals blank. G of x equals -x minus 2 quantity squared plus 5 is the problem. So see this little squared right here? That tells you that this started with a basic graph of x squared. That's what that tells you right there. Your basic graph is this x is squared, so it's a parabola. This thing is going to be a parabola. So the basic parabola is y is equal to x squared. That's your basic one. Then it's going to shift, and there's some blanks to fill in. Shift it, and it has choices there. And then it says reflect across blank and shift it blank units. Okay, for this one, it says left 2, right 2, left 5, right 5. And there are little indicators there for you to decide which one it is. So my shift left and right is right in here. So I'm looking for the 2, but is my choice left 2 or right 2?
Right.
Right 2. That's right. Okay, then this one's going to say reflect across the x-axis or the y-axis. So which way would I reflect it? Remember, this minus is going to flip it upside down like this. Would that be across an x-axis or a y-axis?
Y.
Is it y?
Y.
Okay, if I flipped it across the y, if this was what I started with, and I flipped that thing across the y-axis, do you know it wouldn't change? Because it would be symmetric to the y, so this would be over here and this would be over here. So if I flip it upside down, I'm flipping it across the x-axis. And your answer every time is going to be x-axis because we haven't had any that flip over the y-axis. Then this says up 5, down 5, up 2, down 2. So which one answer is this one on the bottom?
Up 5.
Up 5. To the 5 on the end shifts it up. Remember doing that? Okay, let's look at number 3. Number 3 says you have f of x equals the square root of x plus 1. It says start with, and it gives it to you, f of x equals square root of x, and shift it, and there's a blank there and a blank there, and you have to fill in those blanks with the words. And the first words are left, right, up, down. And the second ones are 1, -1. So in the first one, first blank, would I say this inside shifts it left, right, up, or down?
To the left.
It's opposite of what you think. It's inside the thing. It's a horizontal shift to the left. Okay, do I do 1 unit or -1 units?
-1.
Well, it's going to end up at -1, but you don't want to change the number there, so you put 1. You want to put 1 unit there, not the -1. Now, if you want to see the picture, it'll look like this. And you're going to think that you need to put -1 in there, so be careful. They want it to go 1 unit, but this is what makes it negative, is they're shifting it left negative. That's the negative part.
Okay.
Okay. All right. Let's do number 2. It says you have g of x equals x plus 4 quantity squared plus 2. And it says start with f of x, and they used a different function, equals, what's the parent graph that goes there? This is that parent graph. Remember, this is parabola, so what would be my parent graph?
X squared.
X squared. And then it says shift it blank 4 units. It has the 4 units in there. And then shift it blank 2 units. So then I've got to fill in the right words. So what would I put with 4 units, left or right?
Left.
Left.
And what would I put over here, up or down?
Up.
That's it. Let's look at 1. Determine if the function is even, odd, or neither. And the function looks like this, and it probably will look just like this on yours. So even is symmetric to what? If it's even function, what does it have to be symmetric to?
Digging in my notes, I can't find it.
The y-axis. If it's odd, it has to be symmetric to the origin. If it's neither, it's probably going to be symmetric to the x-axis. So is this one symmetric to the y or the origin? If I folded it along this y-axis,
To the y.
this part be on top of this one? Yep. So that one's an even function. An odd function looks like this. This one is odd. It's symmetric to the origin. Your answer is probably going to be even on your problems, because I think they're all going to be they'll all look like that. It may look this way, but it's probably going to be an even one on number 1. Okay. That's it, kiddos. What do you think? Do you have any others that you want me to work for you that could be maybe from one